Hello students, welcome to today's mathematics session. Today we are going to solve value-based questions from cubes and cube roots. First question is given like this. Students of a school collected provisions like rice, pulses, etc. for the flood-affected people of Madhya Pradesh. These provisions were packed in 6 cubical cartons, each of side measuring 65 centimeter. So here are the two sub-questions asked. The one is find the volume of cartons packed. Second is what values do you learn from the students? So here cartons are nothing but cardboard box whose measure is 65 centimeter, and this is in the form of cubical shape. It's nothing but the edges are of same measure. So here the first question asked is find the volume of cartons packed. So the side of a cube is, so solution, side of a cube is or cubical box is 65 centimeter, and asked you to find the volume. So volume of cube is equal to A cube, or you can write it as S cube. Regarding the volume concept you will learn in the chapter mensuration children. So now you remember volume of cube is nothing but side cube. So that side measures is 65 cube. So this 65 cube can be written as 65 into 65 into 65. Multiply all this and write the product. The answer is 274625 centimeter cube. Since we have 6 cubical cartons, therefore volume of 6 such cartons is equal to, so 1 cube we have 274625 volume into 6 cartons is nothing but into 6. So we get the answer is 164,775 centimeter cube. So this is the volume of 6 cartons. Cartons are nothing but cardboard box. Clear? Now we'll go for second question. What is second question asked is what values do you learn from the students? So we can write helping nature, caring or sympathy, cooperation and responsibility from the student side. So we can write that answer. So we can learn many values. We can learn many values like caring, helpful, sympathy, cooperation and responsibilities. From the students. Hope it's clear, children. Now let me move to second question. Question is given like this. A school decided to award prizes to students for 3 values, that is discipline, cleanliness of environment and regularity in attendance. The number of students getting prizes in the 3 categories are in the ratio 1:2:3. If product of ratios is 162, then find the number of students getting prizes for each value. And second question is name any other 2 values that you can include or that you can inculcate. So here the points to be remembered is prizes, and the values, the prizes distributed are for discipline, cleanliness of environment and regularity in attendance. And here the number of students are given in the ratio. What are the ratio? 1:2:3. And the product of these prices is equal to 162. Then we need to find the number of students getting prices for each value. Then we need to find the other two values. So let us solve the question. First one, find the number of students getting prizes. So here number of students getting prizes are given in ratio, but we need to find in number. So let the prizes given to the students be 1x, 2x and 3x, which are given in ratio. I am removing the ratio by sticking one constant, that is x. Then according to question, what is the question? Product of ratios. So product of these answers, 1x into 2x into 3x equal to, the product is 162. Then multiply the numbers. 1 into 2 is 2, 2 into 3 is 6. X power 1 into x power 1 into x power 1. According to laws of exponents, a power m into a power n equal to a power m plus n. Then here I can write x power 1 into x power 1 into x power 1 is nothing but x power 1 plus 1 plus 1 is nothing but 3 equal to 162. Here the 6 with the x relation is under multiplication, so it changes to division. Divide by 6. 6 ones are 6, 6 twos are 12. Then here remains 4, 6 sevens are 42. 6 6 are 36, 6 sevens are 42. Then x cube equal to 27. Then cube sending to the either side becomes cube root of 27. We know that 27 is a perfect cube. It is a perfect cube of whom? 3. Yes. Cube root of 3 cube. Then cube and cube root, here x equal to cube root of 27. Then x equal to cube root of 3 cube. Then 3 and cube root get cancels. Then the value of x equal to 3. So the constant fixed ratio we got is 3. Then the question asked is, find the number of students for each value. So for discipline it was 1, that is 1x, which equal to 1 into 3 equal to 3 students. Then for the next was for cleanliness equal to, the ratio was 2, means 2x. So 2x equal to 2 into 3 equal to 6 students. Then for regularity, that is attendance. For attendance it is equal to 3x, which is nothing but 3 into 3 equal to 9. If they ask what is the total number of prizes, then you need to sum up all these children. 3 plus 6 is 9, 9 plus 9 is 18. So we'll go for second question. What is the second question? The question asked is, name any other two values that you can inculcate. So here the other two values that can be inculcated are awareness and tolerance. Hope this is clear, children. Now let me move to Brainteasers. Brainteasers, first question, A main. Tick the correct option. In the first question, cube of 0.1 is equal to. So the question is asked, cube of 0.1, which is nothing but 0.1 cube. So 0.1 cube is nothing but 0.1 into 0.1 into 0.1. We know that 1 ones is 1. Then after 0.1 number, after 0.1 number, after 0.1 number, 3 numbers. But here we have 1 digit number. If I write here, it becomes 100. Other numbers, if I make it 0 towards the right side of a number, it becomes 100. 100 in the sense its value changes. So we need to make the zeros at any cost towards the left of a number. So 0, 1, 0, 2, 0, then point. So after point, 3 numbers. So this is the answer. Hope this is the second option in your textbook. Second option is the right answer. So let me move to B question. Question B. The smallest number by which 1944 should be multiplied so that it becomes a perfect cube is. So here 1944, what number is given? It is not a perfect cube. So we need to multiply some number to this, then it becomes a perfect cube. Then what is that number that should be multiplied? Blindly we cannot multiply whatever the number we required. So we need to go for prime factorization and we need to check which factor is not in triplets. Then that factor must be multiplied. So since it is ending with a 4, I'll go with the 2 table. 2 9s are 18, 1 remains, 2 7s are 14, 2 2s are 4. Then again in the 2 in the units place, so 2 4s are 8, 1 remains, 2 8s are 16, 1 remains, 2 6s are 12. Again 2 4s are 8, 2 2s are 4, 2 4s are 8, 2 3s are 6. It is ending with 3 children, so let me check with 3. 3 8s are 24, 3 1s are 3, then 3 2s are 6, 2 remains, 3 7s are 21, then 3 9s are 27, 3 3s are 9 and 3 1s are 3. So 1944 can be written as these two triplets makes 2 cube and these 3, that is triplets, makes 3 cube. And here you can see there are factor 3 repeating 2 times. To make it into triplet, one more 3 is required. Therefore factor 3 is not in triplets. Not in triplets. Therefore 1944 must be multiplied by 3. Keep remember children, here suppose if the factor is 3 is only repeating one time, then you require 2 3s again, means 3 3s are 9. Then we should write factor 3 is not in triplets, therefore 1944 must be multiplied by 9 if the 3 is only one time. If the 3 is 2 times, then one more 3 is required, then we can write 1944 must be multiplied by 3 to make it into a triplet, then the product becomes a perfect cube. Let me move to question C. And this answer children you have in first option, that is option E or first option. So let me move to third question, that is C question. So here find the value of cube root of 10 lakh is dash. So here as I told you in the earlier session that if the number of zeros repeating are the multiples of 3, then we can say it is a perfect cube. So here multiples of 3, these 3 zeros makes one period and these 3 zeros makes another period. Then I can write 2 zeros and here 1 cube is nothing but 1, or cube root of 1 is 1 itself. Therefore its value is 100 children. Now let me move to question D. And this 100 is in the option 3. That is third option, or you can write it as option C. And this is first option and this is second option. Here option is not given A, B, C children. It is given like this. Okay, let me move to question D. Cube root of 0.027 minus cube root of 0.008 is equal to, means we need to find its value. Then cube root of this decimal number I'll convert into a rational number children. So 27 by 1000 will get it, minus cube root of, and here 8 divided by 1000 we will get it, right? So which is nothing but 27. We know that it is a perfect cube of 3 and 1000 is a perfect cube of 10. So 3 by 10 whole cube minus cube root of, then here 8 we know that it is a perfect cube of 2 and 1000 is a perfect cube of 10, so whole cube. Now cube and cube root get cancels, cube and cube root get cancels, which equal to, we know that 3 by 10 is nothing but 0.3 equal minus, and 2 by 10 is nothing but 0.2. So 0.3 minus 0.2 is nothing but 0.1. So the answer is 0.1 children, and this is the option in second option, children. In the textbook it is there in the second option. So this is how we need to find, children, when the decimal number is there. Or there is the another method also. Then this 3 digits makes one period, and these 3 digits makes one period. So 027 is nothing but 0.3 whole cube, and 0.00, that is 008, is nothing but 0.2 whole cube. Then cube and cube root, then 0.3 minus 0.2 is nothing but 0.1. Same fashion, children. Now let me move to equation. So equation asked is cube of minus 1 by 3 is equal to. So here is asking cube of this number, and the rational number is negative, children. So minus 1 by 3 whole cube is asking, which is nothing but minus 1 by 3 into minus 1 by 3 into minus 1 by 3. We know that cube of negative is negative itself, or you can go with like this. Minus into minus is plus, plus into minus is minus. Then multiply all the numerators. 1 into 1 is 1, 1 into 1 is 1. Divide by 3 3s are 9, 9 3s are 27. So this is the answer, children, and this is in third option, children, in the textbook. In the textbook we have third option. So let me move to B mean. Answer the following questions. Under that first one, find the number whose cube is 1728. So here solution. So let us consider, let the number be x. Then x cube, whose cube is, so x cube is 1728. Then cube moving to the either side becomes cube root. Then x equal to cube root of 1728. Let us find whose cube is 1728. So by doing prime factorization, then 2 8s are 16, 2 6s are 12, 2 4s are 8, then 2 4s, 2 3s, 2 2s, then 2 2s, 2 1s, 2 6, then 2 1s, 0, 2 8s, then 2 5s, 2 4s, 2 2s, 2 7s, then 3 9s, 3 3s, and 3 1s. Here also you can stop here, children, because 216 is a perfect cube of 6. Then 6 into 2, 12. 12 cube is 1728. Then x equal to cube root of, these 2 makes 1, that is 2 cube, into these 2 makes 2 cube, these 3's makes 3 cube. Then x equal to cube root of 2 into 2 into 3 whole cube. Then cube and cube root get cancels. Left out is x equal to 3 2s are 6, 6 2s are 12. So 12 cube equal to 12 cube is 1728. So let me move to B question, children. Question B. Find the value of cube root of 216 into minus 125. We know that 216 is a perfect cube of 6 and 125 is a perfect cube of 5. So I'll do it directly, children, here. Cube root of 216 into minus 125, and here we know that negative comes outside. Open the bracket. And 216 you can write it directly, 6 into 5 equal to minus 6 5s are 30. Or you can do like this also, children. Cube root of 216 you can write it as 6 cube into 125 you can write it as 5 cube. Then cube root of 6 into 5 whole cube. Cube and cube root get cancels. Then 6 5s are 30. That is minus 30 because we have negative sign within a cube root. Is it clear? So let me move to C question. Find the cube root of 0.000001. So here solution. He is asking to find the cube root, not a cube. So cube root of 0.000001, which equal to cube root of, check 1. If I remove the decimal point, we have its value becomes only 1. 1, and you see how many periods we have. I mean 3 digits makes one period, 3 digits makes another period. So 2. So 1, 2, that is 0.01 whole cube. Then cube and cube root get cancels. Its answer is 0.01, children. Or else you can go with the another method, that is converting the decimal number into rational number, and then you can find its cube root. Moving towards question D. What is the smallest number by which 1715 should be divided? So here we have to find the factor which should be divided so that the quotient is a perfect cube. So here the given number, that is 1715, is not a perfect cube. So we need to find its factor, children, by doing prime factorization method. 5 3s are 15, 2 remains, 5 4s are 20, 1 remains, 5 3s are 15. We know that 343 is a perfect cube of 7. 7 49s are, then 7 7s are, then 7 1s are. So 1715 can be written as 5 into 7 cube. So here factor 5 is not in triplets. So therefore 1715 must be divided by 5 to get the, that is to get a quotient. To get a quotient is a perfect cube. So that's all, children. Now let me move to question E. Evaluate cube root of 0.512 whole divided by 0.343. Here 3 digits makes one period, 3 digits makes one period, and 512 value, before we have a 0, so it doesn't have any value. So 512 is a perfect cube and 343 is also a perfect cube. Directly I can do, children, this is of one more question. So 512 is nothing but 512 is a perfect cube of 8. So 0.8 divided by, and 343 is a perfect cube of 7. So I can write 0.7 whole cube. Clear? Because this is a decimal place, so we have a decimal point. Cube and cube root get cancels, is nothing but 0.8 by 0.7. And the later part, after decimal we have one digit, after decimal we have one digit, so decimal point get cancels, then we'll get 8 by 7. Or the another method also you can do, children. At the beginning only you can cancel the decimal point, because after decimal point we have same places of decimal, and here also same places of decimal. So decimal point can be cancelled, and then you will get the answer as 512 divided by 343. 512 is a perfect cube of 8 and 343 is a perfect cube of 7. Then you can write 8 by 7 whole cube. Then cube and cube root get cancels. 8 by 7 is the answer. Is it not easy? Yes. Now let us move to the second question, children. Prove that if a number is tripled, then its cube is 27 times the cube of a given number. So here we have to assume let a number be x, and tripled of a number becomes 3x. Then we have to find it. Its cube is 27 times the cube of a number. So let us assume let a number be x. Let a number be x. Let a number be x. Then when it is tripled, tripled is nothing but 3 times, that is 3x. Right? Then according to question, what is the question? That is cube of a number. Then its cube. Its cube is nothing but 3x cube. Then 3x cube. Then what do we get? 3x cube equal to 3x into 3x into 3x. Then first multiply the coefficients. 3 3s are 9, 9 3s are 27. Then x into x into x. We have a exponential law. A power m into a power n is nothing but a power m plus n. Then power, if anything is not there, the power will be 1 here. Then we'll get x cube, right? Then 27 into x cube I can write. Now you check it. The cube of a tripled cube of a number is equal to, okay, tripled cube, that is tripled of a number cube is nothing but 27 times the cube of a given number. So here I can write 27 times. Times is nothing but multiplication under mathematics, clear? 27 times, what is x? X is nothing but a number, and here we have cube. So 27 times cube of the given number. This is what he asked us to prove, that is number is tripled. Number is tripled is nothing but 3x. Then its cube. Its cube means whom? Tripled numbers cube. Tripled numbers cube, that is 3x whole cube. Is in the sense equal to marks. Then 27 times. So 27 into. Then cube of a given number. Cube of a given number. Number is x. Cube of a given number is nothing but x cube. So this is the answer, children. Second question. Now let us move to third question. So what is the question? Write cubes of all natural numbers. All natural numbers from where? From 1 to 10, and observe the pattern. So we need to write cube of natural numbers from 1 to 10. So 1 cube equal to 1. Then 2 cube equal to, 2 cube is nothing but 8. But this 2 cube can be written sum of odd numbers, that is 3 plus 5. Why I have taken 3 plus 5? Because 1 already taken in 1 cube. So 1 is taken here. Then next odd number is 3. So 3 plus 5. How many odd numbers we have to take? Then what we have the base here? So many odd numbers. Clear? Next to 3 cube. We know that 3 cube is nothing but 27. Then after 5 next odd number is 7. So 7 plus next odd number is 9. 9 plus next odd number is 11. So 3 odd numbers sum is 27. Next 4 cube. We know that 4 cube is nothing but 64 equal to next odd number. After 11 next odd number is 13. So 13 plus 15 plus 17 plus 19. So if you sum up all these odd numbers, you will get the answer 64. Next 5 cube. 5 cube, its value is 125, which equal to, so after 19 next odd number is 21. So 21 plus 23 plus 25 plus 27 plus 29. If you add up all these odd numbers, you will get the answer as 125. Next I'll write here, children, 6 cube. 6 cube is nothing but 216, which equal to, we left here 29. So next 31 plus 33 plus 35 plus 37 plus 39 plus 41. Next 7 cube. 7 cube answer is 343. Then which equal to 41 we have ended here. Next odd number is 43. 43, 45, 47, 49, 51, 53 plus 55. You can check, children. 7, right? So 1, 2, 3, 4, 5, 6, 7 odd numbers. Next 8 cube. 8 cube answer is 512, which equal to 57 plus 59 plus 61 plus 63 plus 65 plus 67 plus 69 plus 71. Next 9 cube. 9 cube is nothing but 729, which equal to, after 71 next odd number is 73 plus 75 plus 77 plus 79 plus 81 plus 83 plus 85 plus 87 plus 89. So 9 odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Next 10 cube. 10 cube is nothing but 1000, right? So next, immediate after 89, next odd number is 91. 91 plus 93 plus 95 plus 97 plus 99. Next, 101 plus 103 plus 105 plus 107 plus 109. Once we'll check, children. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 odd numbers. So if you sum up all these numbers, you'll get 1000 here. So this is what he asked. Write cubes of all natural numbers from 1 to 10 and observe the pattern. So the pattern is observed, that is sum of odd numbers. Whereas in the square numbers, children, we used to add the numbers, that is from starting of natural odd numbers. Clear? Whereas here, children, where we are leaving the odd numbers, from there next odd numbers is carried out in addition of numbers to obtain their cube numbers. So 3 cube is nothing but 27. It's nothing but 7 plus 9 plus 11. So like this. Why we have considered here 7? Because in the previous we have ended the odd numbers with 5. So next continuity is 7. So like that we need to add the odd numbers, children. Hope this is clear. And children, let us end with the today's class, children, here. So we'll continue in the next class. Thank you, children. Have a nice day. Thank you.